Back. Let's try that one. Yeah? Okay. Usually in a room this size, I'm used to either being slightly elevated or having some kind of microphone, so I'll broadcast as much as I can. If my voice dies at the end, I'll just kind of mime the rest of the presentation. We'll work our way through it. I want to thank you all for coming out tonight, obviously. You've already been thanked profusely, so I'll thank you again. Thanks for coming out to see me. This is Unit Testing Patterns and Antipatterns. This talk takes about an hour and a half to deliver, give or take the number of questions that we have. Just to sort of level set expectations. If you've got to leave ahead of time, I won't be insulted, honest. So we'll just play it by ear and see how it goes. Before we get into this presentation, though, I do a fair amount of public speaking, and like anything that hopefully all of us do, we try to get better at what we do. So if you have feedback that you would like to provide me after this meeting about what you liked and what you didn't like, by all means feel free to come up and tell me so. I really don't mind the criticism, and I, like anybody, love praise. So tell me about how I'm doing. It's how I get better at what I do. If you don't feel comfortable coming and approaching me, or you don't think of your comment until after we've already left, this URL here that's on the screen takes you to a response page where you can provide feedback about this specific delivery of this specific talk, right? So unfortunately, it won't make it any better for your experience, but hopefully it'll improve it for the next person who's got to sit right where you are next time, okay? In addition to that, I also have a number of these feedback forms here, which Telerik has provided me. I'm going to start them here, and if you could just take one and sort of pass them around the room. I don't know that there's necessarily enough for one for everyone, but just keep going until you run out, and if you run out, we'll work something out. Basically, the idea is you complete that, fill out your information. You do agree that Telerik will send you exactly one email in response for you completing the form. And because I was on the committee that worked with them to figure out what exactly that text should say, I can guarantee you it will be exactly one email. You are not going into an eternal spam list, all right? So you are agreeing to be contacted by Telerik exactly once as a follow-up to your participating in this meeting by completing that form. If you do complete the form, then you will be entered into the raffle to win one of these wonderful squeezable Ninja heads. I have 3 of them, and because that's nowhere near enough to get you to complete the review form, I also have a license of the Telerik Ultimate Suite to raffle off as well. That's either $1,500 or $2,000 value, whatever the heck it's priced at nowadays. So hopefully that should be enough to get you to complete the survey form. So, and again, anything doesn't fit on the survey form you'd like to tell me about, by all means, either approach me afterwards or see me at this URL. So a little bit of background about who I am, and more importantly, why you should care what I have to say. My name is Steve Boland, as has been mentioned a couple of times. I read books and write software for a living, which is as opposed to the alternative career of reading software and writing books for a living. There's nothing wrong with the second career. Plenty of people do good work there. But my career is the first one, where I write a lot of software, hopefully informed by lots of books that I read. But ultimately, a lot of what you're going to be hearing today is based on my own experience, having written software for a very long time, rather than just read a lot of books about it. I have a blog, I record screencasts, I speak at events like this so that I can share what I know with others, but also so that I can learn from people in the audience too. So in my presentations, generally speaking, I'm not a big fan of the sort of lecture-lecture-y kind of dynamic. I have to be up front so you can see my presentation and all that, but I prefer a little back and forth. So if during the presentation you have questions, comments, whatever, feel free to raise your hand and get my attention. If you're not getting my attention by raising your hand, feel free to shout out. If that doesn't work, throw something at me, preferably something soft. And I'll be glad to go on ahead and interact with you during the presentation. Do not feel like we have to save all the Q&A for the end, right? So a little about me. I've been developing software for the better part of the last 20 years in a fairly wide array of languages, starting out with Lisp and then moving slowly through the big fat middle of the Microsoft tech stack for a while, settling in on Ruby and C# nowadays. I'm presently a senior engineer with the Spring Source division of VMware, the people who make the virtualization platform, where I've been for the last couple of years. I'm the co-founder of the New York City Alt.NET user group in Manhattan, where we meet monthly and talk about fun .NET topics. I'm also the co-organizer of the New York City Domain-Driven Design user group, also meeting in New York, of course. In addition to that, I'm a contributor to a variety of open source software projects, probably the best known is the Hibernate Object Relational Mapper, but also things like NDB-Unit, which we'll actually be taking a look at today. And in my capacity for Spring Source, I'm the technical lead and chief evangelist for the Spring Framework for .NET, which is where I spend my day job. I also have a blog here at unhandled-exceptions.com. You can reach me via email here at Gmail, follow me on Twitter. I'm also a member of the ASP Insiders, C# Insiders, and the Telerik Insiders. In addition to all of that nonsense, I'm also an MVP. This year in Visual C#, past years in ASP.NET and Solutions Architecture. So this is sort of my NASCAR style slide where you get to look at all the logos and all that, but it gives you a sense as to sort of where I am, where I've been, how I spend my time, and a little bit about me. So I mentioned Telerik a couple of times. I do not work for Telerik, as the past slide just demonstrated, but obviously it cost money to fly me here from New York, and a big chunk of that money was paid for by Telerik as part of my participation in their Insiders program, where they pay people like myself to travel around the country when we have an opportunity and speak to groups just like this. So in exchange for that, you not only get to fill out the survey eval form there that I've been passing around, but you also have to stare at this slide for a second. So this is a collection of all of the different products that Telerik actually makes. How many people are familiar with Telerik? Yeah? As the UI control vendor, right? What they're primarily known for, right? They make WPF, Silverlight, MVC, ASP.NET controls, those kinds of things. But they also have a wide variety of products in other areas too. They make testing tools, they make decompilers, they make mocking frameworks, they make reporting tools, they even make a content management system. So if you're familiar with Telerik, even in the UI control space, I would encourage you to go to telerik.com and take a look at their wider array of products. Very nearly, I think, everything on this slide is actually in the Ultimate Collection we'll be raffling off at the end of the day. So, but just to give you a sense, they do have a fairly wide variety of stuff. And they are one of the primary reasons that I'm able to be here today speaking to you. So if you like what you hear, please find a way to tell Telerik. And if you don't like what you hear, don't tell them, because they'll stop sending me places. I also want to thank Ineta, who is also paying some of the freight for getting me here as part of the Community Speakers Program. The Community Speakers Program is designed to provide me a moderate stipend in order to allow me to sort of reach a little bit beyond my geographic region. Obviously, Omaha is outside of the New York geographic region. So the interesting thing about the Ineta Regional Speakers Program is that anyone can join. Right? So all of you here in this room, if you would like some kind of moderate compensation for traveling around and speaking to user groups in your area and region, you can join the speakers program, and if you're requested by a user group through that process, then you will get a stipend to cover some of the costs of your travel, up to a maximum of about $200. Since it's based on mileage, the odds are that just about every place in your region other than Omaha probably counts for the $200 maximum. For example, if there's anybody in this room speaking at the Lincoln Code Camp, there's probably $150 to $200 worth of travel costs that could be compensated for you if you were part of this program. It doesn't cover attendees, unfortunately, but it does cover speakers. Right, so I would encourage you, if you're interested at all in getting involved in speaking in your area, then by all means visit ineta.org and sign up for that speakers program. Lots of good opportunity there. The old Ineta speakers program from years ago was invite only, but the community speakers program has for years been open to all comers. So by all means, join up. So, how did this slide get here twice? Yeah, so if you followed me on Twitter at all, and of course you probably didn't because you didn't know what my handle was, you'd have discovered that right before giving this talk, I managed to completely delete the slide deck for it. So, in rapidly reconstituting it quickly in time to deliver it, apparently I copied the Who Am I slide twice. We've already talked about questions. This is just reiterating the idea that if you have them, feel free to shout them out and get my attention. I'll be spending some time heads down coding during this talk, so if I don't see your hand again, just shout out. So before we get into this too far, I need to sort of get a sense of where the audience is in terms of their experience with our topic, and tonight's topic is unit testing. So how many people do unit testing in their daily work? Awesome. Very nice. How many people have tried and given up? Okay, that's fair too. How many people looked at it and said, what a waste of time? I appreciate your honesty. Okay, no, that's good. It gives me a good sense as to sort of where we are. Today's talk is about patterns and anti-patterns in unit testing, of course, so it's probably worth it to define patterns quickly. So in software engineering, we say a design pattern is a general reusable solution to a commonly occurring problem, right? So we find ourselves faced with similar problems over and over. We tend to solve them in the same way. We want a way to sort of have a shorthand to talk about the way in which we solve the problem, and so we invent a name for that pattern, and we use it to converse amongst ourselves, right? So what's an anti-pattern? So in software engineering, a design anti-pattern is a general reusable solution to a commonly occurring problem that leads to commonly occurring problems in software design, right? So just like the pattern is there to be a shorthand for things that are successful, right? The anti-pattern is there to be a shorthand for things that typically seem immediately successful up front, right? But long-term tend to lead into problems, right? Because the thing that is not successful immediately, we just sort of discard, right? We never really do it again, right? But the anti-patterns tend to be those things that on their surface feel like a good way to do things, but long-term tend to end up generating us more and more pain, right? So when I first started to put this presentation together, this was sort of the mind map diagram that I had put together in order to try and think about all the things I wanted to cover. This is about a 4-hour talk, so we're not doing that one. We're going to pick some of these and zero in on them, okay? But just to sort of collapse the diagram for a minute and think about this, right? It runs the gamut from how do we run tests, to how do we keep them fast, to how do we name them, how do we deal with false positives, how do we talk about test coverage, right? A whole array of things. So there's lots of stuff that we're not going to talk about tonight just because time won't allow, but this is kind of the universe of things that came to my mind when I talked about patterns and anti-patterns initially. So we're going to talk about, first of all, just the challenge of running tests, right? So, whoops, sorry. So there are a lot of different ways to run tests, right? And they tend to run the gamut from the sort of very heavyweight visual tooling, right, that allows us to sort of have expandable trees and hierarchies where we can view our tests and we can right-click on them in a little test explorer and click run and run again and run with debugger and all these kinds of things. And the real trick with running tests is that what we want to do is we want to pick the thing that allows us to get to our test fastest, right? And my own experience is that the heavier weight graphical test navigation style things don't tend to provide that, right? The tree view, right, for example, right, imagine that you're searching for a file in your file system, right? The slowest way to find that is to slowly expand every folder until you see the file you're looking for, right? It works, but that's the slowest way to find the file you're after, right? There are a lot of faster ways to find that file, whether it be search or all kinds of things like that, right? So generally speaking, when we're running our tests, we want to try and select a test runner that's fairly lightweight and fairly speedy and doesn't have a lot of this graphic overhead, right? Which isn't to say that there's not a place for the graphic test runner, right? The graphic test runner, just like the Windows Explorer file tree kind of thing, is excellent when what you're trying to do is explore something, right? Learn how the tests are related to each other, learn who has chosen to group which tests together, and these kinds of things. But generally speaking, they don't represent, in most cases, the best way to run the tests. So what I have selected as my test runner of choice, and this is just me, is I use an add-in for Visual Studio called testdriven.net, which makes it very easy for me to simply place the cursor inside the test I want to run, and with a very simple keystroke, very quickly execute the test, right? Equally as importantly, one of the things that testdriven.net gives me is the ability to re-execute the last test, no matter where I am in my code base, right? So when my workflow is, I've got a test that's failing, and I'm over here fixing the code, making it pass, and I want to rerun that test now to see whether or not it's now passing, I don't have to go back to that test to run it, right? I've got a keystroke that allows me to say, run the last test, wherever the heck it might be, right? And it remembers what that last test was. So I can be over here in the production code trying to make the test pass and not have to ever really navigate back to the test in order to keep running it over and over again, right? In the scenario where I'm using the graphic test runner, I've probably got to, slide out some rollout panel, click down, right click on it, hit the little green arrow that says run and all these kinds of things every time I want to run them, right? So this is friction in me moving back and forth between production code and test code, right? So our first challenge, of course, is how do we run these tests, right? So we want to try and pick something that suits our workflow, right? If your workflow doesn't match mine, then probably my suggestion of the tool is not appropriate, right? But I would just encourage you to think through what some of the options are. Another challenge that we face in the case of our test is speedy tests, right? So since everybody in here has probably done, most people here have certainly done a little bit of unit testing at least, right? Probably all familiar with the situation where we start the project and it takes, a second and a half to run all our tests. We're very happy. So every time we make a test, or make a change to the code rather, we run our test, takes a minute and a half, real good feedback loop, right? Over time what happens is that minute and a half becomes 5 minutes, becomes 10 minutes, becomes 15 minutes. Pretty soon it's an hour and a half. So what ends up happening with the problem of test performance is instead of actually running all the tests, what you start to do is you start to shortcut the process. You start to pick which tests you think represent tests about affected code, and you run just those, right? And you just trust that the other tests aren't really going to fail, right? But the whole point of the test is really to provide us with that feedback loop about the entire code base. And so as our tests get slower and slower, we get friction about wanting to run them. And I've run into development teams where it's like, I notice you have all these tests, how come you have all these bugs? I say, well, we never run them, it takes 3 hours, right? So we want to do, in the case of speedy tests, as a pattern to address this, is a lot of people get hung up on the whole notion of Is it a unit test? Is it an integration test? Is it a user acceptance test? Is it a this test? Is it a that test? I would submit that all of those distinctions are interesting to debate in a classroom somewhere, but in the real world, the real distinction that I have found matters is the distinction between fast tests and slow tests. Right? And which isn't to say that all slow tests can be made fast tests, right? There are lots of very good reasons why some tests are slow, right? There are slow unit tests, there are slow integration tests, there are fast unit tests, there are fast integration tests, right? So the distinction there is we want to stop getting into this, I'll categorize all my tests over here as integration tests, all my tests over here as unit tests, whatever it might be. What we want to do is we want to start distinguishing between faster run and longer running tests. Because we want the ability to very easily run the faster running tests as frequently as we possibly can, right? And we want to take the long running tests and run them less frequently. So as an example, right? Let's imagine that I've got some tests that are fast and some tests that are slow, right? One strategy is while I'm working in the code base on my workstation before I commit it back to source control and all kinds of other fun things, I'll keep running the speedy tests all the time, right? Make a minor change, run the speedy test, and see what the feedback is. Make another minor change, run the speedy test, make sure everything still works, right? Because they're speedy, I can run them in that, whatever the number is, right? And the interesting thing about speed, fast tests versus slow tests is the cutoff, where a slow test starts to become a fast one and a fast one starts to become a slow one. It's entirely a matter of personal preference, right? Some people don't consider a 15-minute test slow, right? Some people consider anything more than 30 seconds slow, right? For the entire test suite, right? Not even just one test, right? So we're not even talking about just one test, right? We're really talking about all of the fast tests together. What does that equal, right? So you want to find that happy middle ground, but what you do is draw a line in the sand and say everything to this side is a fast test and everything to this side is a slow test. And so while I'm working on the code base on my workstation, I'll keep running all the fast tests. Now it's time for me to commit my changes to the source control system and share them with the rest of my team, right? Now I'm going to run all the tests, including the slow ones, because I don't want anything broken to go back up into the universe of code where I start sharing it with people, and then they think they can depend on broken code because they start pulling stuff down that's busted, right? So that's one strategy, right? Another strategy that often works, and how many people use continuous integration servers here? Yeah, a fair amount of us, maybe a third or so, 20, 30%. So another strategy that works extraordinarily well is taking the tests and chopping them into thirds, right? Fast, medium, and slow, right? The really slow ones will only run once a night, right? We'll have the build server scheduled to do that at like 2 a.m. all on its own, right? Where we don't really terribly care too much, right? I've seen lots and lots of teams get away with moving really their entire integration test suite, which by and large tends to be the slower moving stuff, and run that every night, right? So it depends on the degree of coverage and the degree of safety and comfort that your fast and medium speed tests produce for you, right? But if that's a fairly decent amount of coverage on the code base and you feel fairly comfortable about that, it might be okay for us to only discover that the whole system doesn't quite work anymore once a day, right? But the point is, right, do it offline, right? Do it asynchronously. Don't have it be, I make a change, I run the tests, I visit Twitter, I check my Facebook account, I get a cup of coffee, I might go out to lunch, right? This is not a workflow, right? The idea of unit testing is, at core to the idea of unit testing is that the shortest we can make the feedback loop between the time at which you make a mistake, the time at which you introduce a bug, and the time at which that bug is discovered, right? As much as we can compress that, that's a win, right? And the reason is, if you think about it for a second, right, that when you're working on you're working on a method, right? You're working on a method in a class. While you're working on that, you have built a very complicated mental model of the way that method in that class and the whole rest of the system behaves, right? You spend a fair amount of time thinking that through. You've sort of loaded all that up into active memory, right? This is what we mean when we talk about developers really sort of getting in the zone, right? And then the phone rings, you're knocked out of the zone, you get to start over again, right? But this is why that's so problematic, because the problem is that you build a mental model, and your mental model is flawed. Because if it wasn't flawed, you wouldn't have put the bug in there, right? So something about your mental model either is an assumption that's wrong, or something you overlooked, right? There's something missing from the model, right? Or there's an extra thing in the model that's wrong, right? So if an hour goes by before you discover you did it wrong, then when it comes back to fix that bug, you've got to rebuild a mental model before you get started fixing the bug. Who thinks they can rebuild the same mental model the same way twice? right? You can't. Because once you've cleaned it out, you're going to have to start again, right? And that's just if 5 minutes to an hour goes by. Now a day, a week, a month goes by, right? It's disastrous for that bug to lay dormant like that long, because when you rebuild the mental model, you may catch that mistake because you've got a bug report about it. You may introduce a whole other one because now you've built a different instance of this mental model that's probably flawed in a whole different way, right? So what we're trying to do with unit testing is compress that feedback loop so that hopefully 5 seconds after I write the bug, I can find out it broke something, right? That's what we're trying to get to, because then the odds are I've probably got the same mental model still in place, right? So over time, I'm refining the same instance of that mental model, getting it ever better, getting it ever more accurate until the code behaves properly, right? Not starting again from scratch and rebuilding that mental model, right? And that's why compressing that feedback loop matters so much, and that's why speedy tests are so damn important, right? It's not because, you know, it's inefficient for you to spend an hour watching your coffee boil while you wait for the test suite to run, right? And that's true, that's dollars down the drain. But it's really because the danger of you fixing the bug right really just, the chance just goes down the more time goes by, right? So, another interesting challenge is the whole issue of naming tests. So we've probably all seen the most common scenario here, right, is the object and object name with some kind of test suffix, right? It can be customer and customer tests, customer and customer dot tests, customer and customer in a test folder, right? It doesn't matter, right? But there's a one-to-one matchup between the class under test and the test fixture that's actually performing the testing, right? And we all do this, and it's very, very easy for us as an organizing paradigm because it sort of follows, right? And it's easy to find because I say to myself, well, where are the tests for the customer object? Well, they're in the customer test class, right? Very simple to navigate, very straightforward. And obviously a relationship we can explain. Do we have tests for the customer? I don't know. Is there a customer test class, right? Real easy. So where this starts to break down is when you need to start thinking about tests that involve more than one object, right? So let's imagine that in order to ship an order to a customer, we actually need an instance of the customer object and an instance of the order object, and it's going to be used by some shipping service. It's going to take the customer and the order and do some magic to it and ship it somewhere, right? Where does that test go, right? Is that a customer test? Is that an order test? Is that a shipping service test, right? Could be any one of those three, right? It's very context dependent on what kind of system you're building and what the logic is, right? But what it points out is that you can't really write all your tests as though they're just about one class, right? In most non-trivial systems. You can get away with the object.test strategy for quite a long time, right? It really does work, right? But that's why ultimately I believe that's an anti-pattern, is that it doesn't scale well and it won't last. It's fine when you're starting out building your system, but over time you begin to discover that that sort of naming convention falls apart, right? So what we look at instead as a pattern here is the idea that if we think about the reason for having a test fixture in the first place, right? I mean, one reason is that we, you know, in object-oriented software, we can't just write a test method and not put it in a class somewhere, right? So we're stuck. But the real reason that we have a fixture, right, is because it encapsulates common setup and teardown operations for us, right? So if instead of thinking about, you know, so as an example, right, what do you do with the customer test thing when some of those tests are about how the customer behaves when it's valid, and some of those tests are about how the customer behaves when it's invalid, right? You can't use shared setup methods because in one case you're creating a valid customer, in another case you're creating an invalid customer, right? You can get away with it, right? You force it, right? You make a private field called valid customer and a private field called invalid customer, and then you have a setup method that creates both, and all the rest of this stuff, right? But now what you've got is you've got this customer test fixture doing at least double duty, and it's sometimes triple and quadruple and more on, right? And so eventually this just becomes a big giant ball of mud, and no one can figure out what's going on inside there. It's also the source of all kinds of bugs, because you've got valid and invalid customer objects floating around in space as a result of these common setup methods. And if you're smart enough, you've named them valid customer and invalid customer. But if you haven't, and you've named them customer 1 and customer 2, it's real easy to get those confused, right? Especially as you're maintaining these tests over time. So there's another reason why that sort of one-to-one matchup doesn't really tend to work well. But instead, if we think about this as the reason for the fixture being common setup and teardown, then what we start to think about is we start to think about conceptually a more scenario-based organization for tests, right? where the things that the tests and the fixture have in common is that they share the same setup. They're all about the same context in which the objects are going to be exercised, right? So if instead of saying, let's just have customer and customer tests, what we have is we have customer is valid tests, right? Now we can assert all kinds of things and test all kinds of things about what should happen in our system when we have a valid customer. And over here we have another fixture that's about invalid customers. And we can assert and test all kinds of different objects about the condition where our system is interacting with an invalid customer object, right? And that can be something as simple as it doesn't have an address, it lacks a last name, it doesn't really matter, right? But the point is that what that does is that allows us to then use setups and teardowns intelligently. Because now it is true that one setup is all about creating valid customers, and another setup is all about creating invalid ones. Yes?
We do something similar to that, but we still follow the naming convention of customer tests followed by something, customer tests for invalid customer, customer tests for valid customer, so that the muscle memory we've built for, okay, in ReSharper go-to type customer tests will work because there's these things with the leading prefix.
Yep. So that's not all that uncommon at all, right? So what you're doing is you basically have an outer class that is all about the name customer tests, for example, right? And you've got an inner fixture that's about when it's valid and another inner fixture about when it's invalid. Is that what you're doing?
No, we've actually got separate top-level classes, but the name is
so
a
we're
prefix.
oh, so it's like
tests
customer
for-
tests like underscore invalid underscore valid conceptually.
Something like that.
Okay, yeah, that's not uncommon either, right? And it's kind of a mix between the two, right? Where that comes into a problem, however, is when you now have like the object collaboration problem that I was talking about earlier, right? And so some mix of that can work, right? But that's where I think you eventually run into a little bit of trouble. Yeah.
I guess elaborate a little bit on why the general. I guess the way I tend to build it is you've got two objects and then you've got your collaborator, your service object or whatever. And it seems to me that the ones that pull in from both would naturally go with the service test. I guess
So that works when there's a third one. What if, for example, right? I just give you an example, right? What if this test is about adding an order to a customer, and some of that behavior is the customer validating the order, and other of that behavior is the order agreeing with the customer that it's okay for it to be added, right? Now we don't have a third place, right? So we don't have that, right? And I agree with you in the case where you have the coordinator object, right? That is sort of choreographing the other objects, then yes, I think you're right. The order placing service tests is kind of where that goes, right? But when you don't have that object, now it becomes a problem. And one of the core thing about naming that I will throw out there, right, is the same core thing about naming anything in code, which is whatever the heck you pick, be consistent about it, right? And so when you try to be consistent about customer and customer tests and so on, but that doesn't apply everywhere, what you end up is this weird situation where I've got customer tests because some tests really are just about the customer. But that's not really where all the tests that are about customer go, because some of the tests about customer are actually also over here, right? And so it leads to sort of a false sense of proper navigation when you think you're now staring at all the customer tests, but it turns out some of customer behavior is really tested over here, right? And that's where the challenge comes in with that kind of strategy. So what I would encourage you to do, right, is I would encourage you, so I guess, we should go back for a moment and talk about, patterns and anti-patterns, right? Patterns are not laws, right? And anti-patterns are not laws either, right? So part of the point of a pattern is that generally speaking, in most cases, when you do this, you'll be okay. And an anti-pattern is generally speaking, in most cases, when you do this, you will experience pain. It is not the case that every time you follow a pattern, you're on the road to guaranteed success, and every time you follow an anti-pattern, you're going to just, die a horrible death, right? That's not the meaning of patterns, right? That's why we don't call them laws and theorems and these kinds of fun things, right? So what I would encourage you, stepping back for a minute, I would encourage you to take what I'm talking about and sort of internalize it and project it properly into whatever work context you guys are living in that is appropriate for your case. Yeah.
So with your example of the customer and order kind of collaborating with each other, how would you name that scenario? How would you name that test?
So what I would do is I tend to want to name my test scenario based in terms of what the context is that the test is going to be running in, right? So what I would do is I would probably end up with a test named something like, when customer and order is valid, right? That might be my fixture. My test is going to be, can add order to customer, right? So the way my failure is going to read is when customer and order is valid, can add order to customer, failed. Right? And so what I'm doing is I want the errors coming back to me, right? So this kind of gets to one of the. So let's talk about the best case scenario for a unit test for a minute, right? The best case scenario for a unit test is that when I run it and it fails, the combination of the name of the fixture and the name of the test and the message in the assert are all by themselves sufficient information for me to look at that and go, I know exactly where that problem is, I'll go fix it. Okay? The worst test is the test fails and the next thing you do is fire it up with a breakpoint somewhere. Okay? Because then you've lost the benefit of the test, right? Or one of the major benefits of the test, right? So generally speaking, and this is, again, patterns and anti-patterns, right? If your test fails and your next step is I need to put a breakpoint and run the test through the debugger and look at the watch window and figure out what the heck's going on here, it is generally the case that your test is not specific enough. Either in its name, or what it's testing, or what it's asserting, or the feedback that it's providing you when the assert fails, right? The best case scenario is the combination of all the metadata that the test runner returns to me on failure tells me immediately where the problem is, right? So what I'm looking for in that case is I'm looking for the thing to tell me when the customer and the order are valid, can add order to customer. If that fails, then that tells me the behavior of my system that's broken, right? Not expected 1 got 2, right? It tells me immediately that the code I have in front of me, the following capability of my system no longer works, right? And that gives me the beginning of figuring out what's actually going on. Now, hopefully, the assert that happened to fail in that case is telling me specifically why I couldn't add the order, right? For example, I don't know, order was for an item whose color was blue. I don't know, right? I mean, I'm making stuff up. But the point is, right, that what we want to do is we don't want to have to be in the debugger, right? Arguably, right, what a test is at its core, and I really do firmly believe this because I've seen people do this, right? Imagine you don't have any tests and you're trying to fix a bug, right? So what you do is you put a bunch of breakpoints everywhere and you create a bunch of watch windows and everything else. And so what you do is you invoke the method and you start stepping in and you start looking at the watch windows and everything else, right? So every time that you're looking at a variable in the watch window and you're saying, that's a 1 and it should be a 1, right? That's an assert, right? You're looking at that value and going, yep, okay, that one's good. Then you move on to the next value and you say, oh, that one's good. And you move on to the next one and you say, oh, no, that should be true and it's false, right? What you've just done is you've written a unit test just in your head, right? And so you're going to shut down the debugger and you're going to change true to false and it's all going to be fixed. And you're never going to remember any of those assumptions. You're never going to remember any of the thought process that got you there. And you're never going to be able to reproduce it again, right? And won't be able to is the next dev staring at the method, right? So one way to think of a unit test is a codification of what we expect to see in the code in the debugger as we're staring at the method, right? This is why if when the test fails, my next step is to launch the debugger and walk through it all, then I've got a test that is not written well, right? I'm not saying that sometimes you don't have to debug tests, that's not what I'm saying, but I am saying that if your test should strive for the ideal of the name of the test, the name of the fixture, the failure message, the type of assert that didn't work, all those combined together should give you enough information to fix the problem without your next step being to stare at like 30 values in the watch window, right? 30 values in the watch window means I have no damn clue what I'm doing. I don't have any idea how this code behaves and I sure don't know where the problem is, right? That's way too coarse-grained a way to solve a problem, right? In fact, it's one of the reasons why I really wish the watch window had only 3 slots. Imagine how your workflow would change if you could only really look at 3 variables at a time, right? So the important thing about naming, right, at its core is that you're consistent throughout your code base, right? Just like it's true of production code, right? It's also true of test code. So pick a naming scheme that does work for you, but be consistent about it throughout your code base, right? Don't have Sam's way and Jim's way and Judy's way and all the rest of this kind of nonsense, right? Just like we wouldn't accept that for production code, we shouldn't accept it for test code either. So it turns out, if you think about it for a moment, that very nearly every assertion you have in your unit test framework boils down to something that could be stated as true or false, right? if you think about it for a second, right? When you assert that 1 is greater than 0, right, that's going to return a Boolean. When you assert that this is not null, that's really just returning a Boolean, right, and so on. So it could be the case that every assert you'd ever want to write could be assert true, paren, the statement, assert false, paren, the statement. You could do that, right? And what your unit test framework will do is tell you expected true got false, right? When you get going back to that idea of the metadata that the test runner provides us wants to help us figure out what the problem is, expected true got false is not very useful, right? Expected this object to be in the collection, but it wasn't. Now that's starting to tell me what's wrong, right? But I could just as easily say assert true, collection dot contains this, and it'll say expected true got false, right? And that's not nearly as helpful as assert collection contains this object, because then the test framework tends to respond with expected a collection containing order, didn't get it, right? So generally speaking, we want to avoid assert trues and assert falses. But we also want to realize that at the end of the day, every assert really is an assert true and assert false, right? But what we want to do is, one of the ways that unit test frameworks have evolved over the years is to provide ever richer assertion statements, right? It used to be that if you wanted to assert that the object was in the collection, you had to literally iterate over the object collection yourself and figure out whether it was in there, right? Now there are things like assert contains and assert has this object and so on, right? So we should avail ourselves of those more advanced, and not so much more advanced, but more verbose assertion statements, because they are more specific about what it is we really mean to be testing, right? So generally speaking, we should pick the most descriptive assert we possibly can. Right, we should take advantage of the language that the unit test frameworks provide us nowadays in order to provide these richer assertions for exactly that reason, because we want the feedback from that to mean something to us when the test fails.
One question on that?
Yeah, sure.
Do you find yourself writing a lot of custom matchers to make it more descriptive, or?
Sometimes, though, honestly, not nearly as much as I used to, right? Ironically, at about the time that .NET got extension methods, which would have made it brutally simple to have continued to write my own, the unit test framework started to get pretty much every one of those assertions I found myself needing, right? Sometimes I do, but when I do, I tend to write them as extension methods, right? On assert, right? Because you've got the assert object, it's easy to just write your own extension to that really quickly, right? And oftentimes, right, as we'll see in a second, or later on we start looking at some code, oftentimes we'll find that the exact assertion is provided by the framework library, but we may want one that actually is just a little bit more sort of business-centric as a statement, right? So, but generally speaking, I find nowadays that most of the unit test frameworks, certainly in the .NET space, have now sort of evolved a rich enough assertion syntax that it's now possible to sort of get away from writing my own. But not all that many years ago, you did find yourself doing a lot of that. And of course, before extension methods, it was even more annoying. So the next challenge we face with unit tests is this challenge of repetition. And how many people have heard of DRY as a notion, right? Don't repeat yourself, right, as a principle. So we don't like repeated code. We don't like copy and paste code. We don't like all of these kinds of things in production code. And we don't like them in test code either, right? For all of exactly the same reasons, right? I've worked in a lot of code bases with a lot of teams where the attitude has been, well, it's test code. We really don't care how well it's written. We don't ever bother to refactor it. We don't bother to clean it up. We don't bother to make it more clear. We don't do any of those things, right? Wrong answer. If you're doing it right, the tests are going to live every bit as long as your production code, and you're going to be in there every bit as much as your production code, right? So the idea that it's sort of throwaway code because it's test, not production, is I think, most of us probably have experienced that as a serious anti-pattern. Repetition in code, in test code, is one of those very interesting things because we tend to be in production code just obsessively concerned about repetition, right? And not in a bad way, right? We are constantly pulling out things and creating new methods and all the rest of this kind of thing. And that's because it's more important in production code for us to make sure that we don't have like two different places that behave differently because they just happen to be copy and paste code that, we fixed the bug in A, we didn't fix it in B, where we copied the code, right? In test code, I would say that the same general principle applies, don't repeat yourself, but that we ought to relax it ever so slightly in the interests of a little bit more legibility, right? You will be probably reading more test code more frequently than you will be reading production code. So the legibility factor, right, is always there in any code you write, right? If I am just obsessively, good about structuring my code, but I use, X and Y and Z instead of meaningful variable or parameter names, then I may have a win from the standpoint of, fewer characters and source control, and I've saved a couple of bytes on disk storage. But from a legibility standpoint, the poor developer who's got to follow behind me has to go, why did he use X and not interest rate here, right? Those kinds of silly things, right? So in production code, in test code, legibility plays an even higher factor typically in the code we're writing. And so a little bit of repeating yourself is oftentimes better, because as you're reading the test code, you don't want to find yourself starting on this line and then having to jump over to this file and read the method there, and then having to jump over here and read that in order to make sense of what the test is actually doing, okay? So don't repeat yourself still wants to apply in tests, but I don't think with quite the same sort of militant, no matter what kind of thing going on that we tend to apply to production code, right? There's a little bit higher legibility factor. In fact, I would argue that if you pay attention to the legibility of your tests, and I'm not suggesting that if you have good tests you should go name your variables X, Y, and Z, but I am suggesting that if you have tests that read very clearly, then the obligation that your production code read as clear as humanly possible actually drops a little bit. Because you have the paired up tests in order to explain what the heck is going on there, right? The production code doesn't need to stand by itself and explain itself all by itself anymore, right? It is explained partly by the way it's written and partly by the way the tests for it are written, right? So think about those in combination to each other, collectively resulting in a decent way to understand the code base, right? It's not the case that the production code has to stand on its own. And again, I'm not arguing, therefore, you should create one 10,000 line method nobody can follow and have really good tests, right? That's not what I'm saying. But I am saying that the idea that we always talk about in production code, or any code for that matter, that the code should be self-documenting. It should be written in a clear enough way that we can easily understand it and someone who comes after me can follow along what the heck my intent was, right? And that's still true. But it's not true to quite the same degree as we look at the combination of tests and production code at the same time, right? So, the trick with our unit tests is that we always want them to fail for the right reasons, right? We don't want the fact that somebody changed the name of the mail server in IT to suddenly make our unit test fail, right? We would like to isolate ourselves from that, right? So that's a false negative. My code still works, but some idiot changed something in the environment, so my code breaks, right? The test fails. My code actually is still just fine, but the test is broken, right? So we don't want the false negative. But the false negative is actually nothing compared to the false positive, the test that passes for the wrong reason, right? And the reason for that is that if you have your test suite of 1,000 tests, and you run them all, and 999 of them pass and one fails, what gets your attention? The one that failed, right? Not number 703 that's green, but green for the wrong reason. Right? So we need to obsessively guard against the false positive, the test that passes for the wrong reason. Okay? And this can be, as we'll see in code in a moment, subtle as to why it happens. Right? And I'll show you some techniques for guarding against tests that pass for the wrong reason as we look at some of the code. But you can imagine that scenario, right? You never look at the green tests. They're green. Right? So we always want to make sure that tests are passing for the right reasons, but failing for the right reasons, but we also want to make sure that they're passing for the right reasons, for that exact reason. The word reason appears way too much in that slide. So, faked out. Of those of you who do unit testing, how many of you use mock frameworks of some kind? Right? Interesting, not nearly as many as I would have thought. I would love to know how the rest of you are doing your testing. But that's okay, we'll talk about that. So, for those of you not familiar with mock object frameworks, right, they are the idea that it's possible to get a piece of software that can produce other implementations of our objects that can have behavior we can specify on them, right? So the common scenario is we have an object whose job it is to send email, but every time we run the unit test, we really don't want to honestly send an email to somebody. So we use something like a mock object framework in order to produce a fake version of the object that should be sending the email that never really sends the email, right? And we'll have our test use that object instead, right? And we won't end up sending emails every time we run our test suite, right? So the problem with mock object frameworks is that they enable you to very quickly get tests that sort of spiral completely out of control. To the point where I've seen many, many code bases where we talk about false positives, tests that when you actually sort of dig into what's going on, it turns out that the author of the test is really just accidentally testing nothing but the mock object framework, right? Because they've managed to mock out and stub out and fake out so much of their system that there's actually nothing left anymore in this test that's really being tested, right? And it's pretty easy to do, obviously by accident. It's pretty easy to do on purpose too, but it's pretty easy to do by accident because a lot of these things are very complicated because they're intended to solve all kinds of corner cases, right? So they tend to have fairly complicated APIs with all kinds of different options and all kinds of different ways to make mocks and stubs and fakes and all kinds of other fun named things whose behavior we can control. But it's really easy to get yourself into a quandary here where you think you've got a test that's really testing something and it turns out you're not, right? So we'll look at some techniques when we look at some code here for sort of making sense of the world of mocks as well. But the pattern, the anti-pattern here is to watch out for the case where it turns out you've mocked out everything and your assert is really an assert on the mock whose behavior you just specified. So of course it passes, right? So I threw this graphic up here because I don't know about you, but of all the ASP code that I've ever seen, I'm pretty sure no one ever read the ASP Code Maintenance Handbook. I'm almost dying to find a copy of that because I'd love to see what it says. But the point here, right, is, and we've kind of already touched on this a little bit, is that you really should treat your test code as though it's production code, right? It deserves all of the respect, and it deserves all of the care, and it deserves all of the organization, and all the rest of that your production code does, right? The very same things that we do that make it efficient for us to maintain and continue to modify and grow our production code are those things that need to be used to maintain and continue to grow our test code. Because the two are going to evolve in lockstep with each other, right? We're going to change something about the production code, we're going to be modifying our tests, we're going to add a feature, we're going to need tests for that feature, right, and so on. So this kind of goes to that whole notion that we've already sort of touched on, which is this idea that, oh, it's test code, who cares, right? And that's, I think, a very bad choice in the long run that will definitely come back to bite you if you're looking at that approach with your test code. So, how many people know how unit test frameworks actually work, sort of under the hood? Does anybody ever bother to look at any of the code? Yeah, one of you? Okay, so that's okay. You know, lots of things we don't need to know how they work in order to use them, right? But just like most things, if we do understand how they work, it actually informs the way we use them in a little different way, right? So, at its core, all a unit test framework does is invoke your code and check for an exception. Okay? When you use the assert, and that assert is not satisfied, what the assert does is throw an I was not satisfied exception. Okay? The unit test runner's job is to take that exception and turn it into a pleasing message that it shows you on the screen. But that's what it does, right? You can think of a unit test runner as a gigantic try-catch block that understands your code throwing exceptions and translates them back into this method threw an exception, so it's red, this method did not, so it's green, right? This is why, if you've ever written a test and forgot to put any assert in it at all, that's why it's green. Because by default, if the test runner doesn't see an exception, your test passes. Okay? That's how they work. You could write a test runner yourself by wrapping calls to your code in a giant try-catch block that just kept track of how many exceptions it caught. You could say 30 failed, 10 passed. Right? You could do that yourself. Now, obviously, fundamentally, there's a lot more going on in unit test frameworks, but at their core, that's conceptually what they're doing. They're just catching exceptions. And that's why if you forget an assert, it looks like you got a test passing, right? That's the simplest example, of course, of the test passes for the wrong reason. Right? I never bothered to assert anything, right? There are many more complicated scenarios, but it's worth understanding that, right? Now, how many people have written tests where they check for exceptions? Right? Did you use the expected exception attribute?
Yes.
Used to.
Used to, yes, right. You've been bitten by it at least once, right? So the problem with the expected exception attribute, if you think about it for a moment, is that what it says is you place it on top of the method and you say expected exception of type whatever, right? Could not place order exception, right? The problem with the expected exception attribute, and even unit test framework designers acknowledge this, and they would love to get rid of it, but there's so much code written with it, they just can't deprecate it totally, is that what that is a statement of is that somewhere in this method body, something, I have no idea and don't care what, will throw the expected exception. It could be the thing you think it is, or it might be 3 lines before the thing you think it is, right? And so the problem with the expected exception attribute is not that it's bad to expect exceptions, it's that it's not fine-grained enough about its expectation, right? If you've got 10 lines of code and line 9 is where you think the exception will be thrown, if line 2 throws the exception you're expecting, test passes, even though you never really got to line 9, right? This is another one of those pass for the wrong reason things, right? This is a false positive, right? But understanding how unit testing frameworks work gives us a clue into why expected exception is not a great idea, right? And we'll look at a pattern or two for solving that as well. Of those of you who do unit testing, how many of you capture test coverage metrics? 1 of you, 2 of you, 1.5 of you, 2.5 of you, 3.5 of you. Wow, very small percentage. Interesting. So for the rest of you, just out of curiosity, you don't because you don't believe in their value, or it's too hard to do, or like somebody yell out, why not? Which one?
Too hard to do.
Too hard to do. Okay.
Not sure how to do it.
Okay, that's a fair answer too. Yeah, no, I'm just curious.
So
So,
even if we did have 100% coverage, that doesn't mean we're covering all paths.
right. So, exactly. So let's talk about test coverage, right? So does everybody know what test coverage even is, right? Let's start with that one, right? Sort of? Yeah? Maybe? Not all of us? Okay, let's talk about it. So when we run our unit tests exercise our production code, right? And what test coverage is it's a way for something running the tests to report back on which lines of code it executed as your tests were run. Okay? So if I have a test suite and it runs 100 lines of my production code, and I've got 100 lines of production code and my test suite runs 70% of those lines, then my test coverage number is 70%. Right? When I execute my whole test suite and say what percent is covered by tests, the answer is 70, which means 30% is not. Right? Just in this simple example. Right? So for those of you not capturing test coverage numbers, I strongly suggest you do, and here's why. Okay? Test coverage is what I like to refer to as a negative metric. Okay? Which doesn't mean that it's bad. It means that what we shouldn't be looking at in my example is the 70% that is covered. What we should be focusing in on is the 30% that is not. Okay? Because as all of us who've written a unit test or two know, it's possible to execute the exact same path through the code with different input values and get different results. Now every time I send in a different input value, it's not increasing my test coverage number at all, because it's the same path through the code, right? But having written one test for that path through the code is one thing, and then having written 2 more, right? What happens when I send in negative? What happens when I send in a 0? What happens when I send in null, right? I'm improving the quality of my tests without ever increasing the code coverage number, right? So I'm not getting over 70% in that scenario, right? But I am getting better at the value of the test from my code base, which is why being worried about getting it from 70 to 71 is not my problem, right? That's a wasted effort, okay? But knowing where the 30% is that I have no idea whether I can trust my code about, that's really valuable, right? And that's what I mean when I say test coverage should be looked at as a negative metric. Look at it not for where it says you're covered, but for where it says you're not covered, right? Now, if the 30% of my code that isn't covered by tests is property getters and setters that are auto props that don't even have backing fields, if the 30% is covered that isn't covered is code that, like, you know, we paid some offshore monkey group to write and we don't really care about it and it kind of behaves all right, but it's an inconsequential part of our logging system or something, then who cares, right? But if part of that 30% is something that's complicated, error-prone, of stupendous value to the system, right? Now we got a problem, right? And that's how we want to look at code coverage. We want to really look at this as a code uncoverage number, not a code coverage number, right? Because the 70% of our code that is covered, I've worked on code bases that have nearly 100% test coverage. They still have bugs, guys, right? So even if you could get to 100, right, which is, and we all know, right, part of this is kind of that it's a logarithmic problem where, you know, we keep jumping half again closer to 100, but we never quite get there because the last oomph is like 3,000% of what it took us to get to 99, right? So we don't get there, right? But my point is chasing it is pointless. Don't even look at the positive number, look at the negative. And be sure that the part of your code that's not covered by tests, you're cool with. That's the way to use code coverage metrics, okay? Because if you discover that 30% that's uncovered matters a lot to you, then you got a problem, right? And if it's an inconsequential part of your system that has very simple operating, don't bother writing the tests for it, right? Nobody gets a gold star for 100% test coverage, right? I mean, and if you do work in one of those places, tell them that's stupid, right? You probably won't get the gold star, but your buddies will love you. Right, so that's code coverage, right? We want to look at the uncoverage number because that's the part that matters, right? Chasing the 100% is a waste of time, right? Focus in, test the parts of your system that are the most valuable for those tests, right? Either where the most important work is done, where the most complicated stuff happens, or, even if it's simple, where the most bugs appear, right? By definition, if you keep getting bugs in this little subsystem over here, it means that nobody understands it well enough to be working over there. Time to get some tests, right? So focus in on ROI, right? Don't just shoot for 100% test coverage, right? So organizing tests we actually kind of hit on a little bit when we were talking about the naming convention, right? And that's sort of the scenario or test context kind of organizing paradigm. So we're not going to spend much time on organizing, just sort of jumped into that in naming. So the reality is, of course not this data, but the reality is, right, that when we run tests, one of the things that a test has to do is be repeatable, right? We run it at 9 a.m., it should pass the same test, no changes to the code of the test, it should pass at 10 a.m. Right? It should pass at 9 a.m. 3 weeks from now too, right? So effective unit testing is all about isolation and controlling the environment in which the test runs, right? Testing is all about, given a set of inputs, push through the system, and get the following set of outputs. And if you can't control the inputs adequately, then you can't get reliable output, right? So all unit testing, never mind data dependency for a moment, all unit testing is ultimately boiling down to, can I get a repeatable set of inputs to my system so that I can assert on a repeatable set of outputs, right? So we need to control that state. And data-dependent tests, because in the end we do need eventually to write tests that make sure we can persist things, so if someone knocks the cable out of the power socket, we haven't lost all our data, right? We do need to write these tests, but effective database-dependent testing is also about exactly that same thing. How do we get a reliable, repeatable set of inputs so that we can assert on a reliable, repeatable set of outputs, right? So how many of you work with the shared development database between your development team? Ouch. So for just about any database platform you're on, right, whether it be SQL Server, Oracle, even DB2, there are free, lightweight versions of these products which you should immediately install locally and stop using the development database. I'll tell you why. What happens if I'm running the test suite and you insert an extra record into the database in the middle of my test run? My test fails, right? So what I have to do instead is we have to send an email saying, you know, by the way, everyone stay out of the test database for the next hour because I'm going to run the database tests, right? So we want to avoid that wherever possible because just like I wouldn't want you reaching in here and sort of, you know, changing a 1 to a 0 in the middle of my test run, I don't want you reaching into the database and changing the values as I'm running through the tests either, right? So we definitely need to isolate the database target in some meaningful way. Now, if you can't, for a variety of internal IT reasons, install an extra database somewhere, even locally on your workstation, whatever it might be, then work with somebody in your organization to find some other database over here that we call the database we'll test against. And it's different from the development database, right? Because while I'm doing my development and I say, you know what, I need to make sure this form works right, what I'll do is I'll hit F5 and I'll launch the form and I'm connected to the test database and I'll save a new customer record. Now your test fails because there's an extra customer you didn't expect, right? So we need to isolate the environment that our test is running from any external changes, right? Whether that's intentional or accidental. And so database dependency, as we'll see in a moment, is really all about the exact same thing any kind of testing is, which is controlling the environment in which the test runs, right? So that is not just making sure nobody inserts an extra record, but if you think about it for a minute, it's also making sure that we have consistent test data as input, right? so that we can assert consistently on the output. And we'll look at some techniques for that in a moment when we look at code. So, how many people have heard the "you should only have one assertion per test" mantra? Not only follow it, how many have heard it? Okay, so the one assertion per test mantra comes from the value that I was trying to espouse earlier when I was saying when your test fails, we want the failure message and the test that's running and all the rest of that metadata to tell us enough about the problem so that we know how to go fix it without stepping into the bugger in the test as our next move, right? And if there are 3 and 4 and 5 different things being asserted on, right, it becomes much, much harder to figure out what the heck went wrong, right? So came the one assertion per test rule. Now, a lot of people are sort of militant about this and say what that means is that I can really only use the assert word once in my test method, right? That's not actually what was meant by one assertion per test, right? That's sort of one actual assertion, right? One physical, technical assertion. What we really mean is one logical assertion, right? Some things take 3 and 4 and 5 assertions in order to collectively assert that the logical state of the system is actually what we expect. And that's fine, have 3 and 4 and 5 of them, right? But don't assert that an email was sent, the order was placed, it was persisted in the database, and, you know, today is Tuesday, right? Not all at once, right? It's fine to need to assert all those things, but let's have different tests for those.
Is that related to the arrange, act, assert pattern?
It is related to the arrange, act, assert, right? And what we want to do in our assertions is we really want to focus in on a collective logical state of the system, right? So maybe what we need to do is assert that we placed an order. And there may not be a status of the order called, you know, order placed, right? So it may not be that simple to assert that we really did place an order. It may take 3 and 4 assertions to assert that we placed an order, right? A simple example, probably not in most systems, but you get the point, right? It might take 3 or 4 assertions to really be sure that the condition of the system is what we expect. That's fine, write 3 or 4 of them. But there are 3 or 4 assertions about a single state of the system, right, that we need to assert is true at that point, right? So the test is really only testing just one thing, and that's where we get to this notion of one assertion per test as a mantra. So now let's look at some code. So I'm not certain, you guys in the back will have to tell me. Can you guys see that in the back? I was afraid of that. Unfortunately, I don't know how to get the projector further away from the screen. You want to hold it in your lap in the middle there? Well, it's not making me dizzy. I don't know about you guys. Unfortunately, I think that's about the best I can do. I can go a little bit further, and let's just play a game. Let's go a little larger on the font and see if it's even possible to see more than a line of code on the screen at a time.
Yeah, you can control and scroll up.
That's true, I can, but that will only solve the current window, and I'm going to be switching around to lots and lots of code. So let's wait 20 minutes for Visual Studio to scan all my installed fonts. Let's try 16 point. Is that any better? All right, we'll try and go with that. We're not going to be able to see much code on the screen, but that's okay. So this part I got covered. So we have a relatively straightforward project here. It's got, we'll just collapse. Oh boy, low res. There we go. Or not. Did everyone see me click on that? Come on, baby. There we go. Not liking it. Okay. Score 1 for Visual Studio. All right. So what we've got here is we've got a couple of different projects in my solution. I've got a console app, which I won't bother running. I've got a domain model here. I've got something that does persistence. I've got something that deals with maintenance. We'll talk about that in a minute. I've got a collection of tests there called managing orders and items tests as a project. I've got some persistence tests, and I've got some placing and shipping orders tests, right? So we can already sort of see, right, how I'm using scenario-based organization to sort of name my tests, right? So we can imagine, of course, that these are all tests about managing orders and items, right? Not surprisingly. And we've got things in there like when customer has an order, when customer has no order, when an item has zero cost, these kinds of things, right? These are all the context in which I want to then assert things about the behavior of my system, right? So let's take a look at a simple test. And what we're going to do here is we're going to take a look at each one of these, not all of these tests, of course. We're going to take a look at several of these, and we're going to sort of walk through what's wrong with them. Okay? So here's a test, right, where we've got, right, customer and orders test, and we say when customer has an order, we can remove the order, right? So in order to do that, what we do is we new up a customer, and we new up an order, then we remove the order from the customer, and we assert that the customer does not have that collection of order, that object in its collection, right? So who knows what's wrong with this test?
Actually test that the order's not in the customer.
Right, I never added the order to the customer,
Yeah.
right? So, of course it's not in the collection, right? So, obviously, right, the right way to do this is to call, I'll have to wait the first time I use IntelliSense, it falls asleep. We'll have to do customer.addOrder and add the order, right? Now, of course, if we run the test, you're not going to get the full call stack because part of its job is to turn an ugly looking call stack into a pleasant looking exception. So without the debugger, you're not going to see where that line actually threw from, right? You do have to look at it at that point, right? I suppose another strategy would be to wrap absolutely everything in a try-catch block, but obviously that's ridiculous, right? So I think at that point you definitely start using the debugger. Yeah.
I'm not sure what test-driven.net does, but I know ReSharper's test runner will give you a stack trace just fine. And so will the NUnit Google.
Yeah, it's true. It will. That's true. That's true. I think with I know why. You know, I have that turned off because I don't like the extra data. So you're right. It actually does provide a stack trace. Yeah.
I would point out though that to your previous thing, to your question, that it's not actually the failure that's happening isn't actually the failure that you're trying to test.
That's right.
So you're getting a failure that you weren't
Should've failed
expecting to
somewhere
get.
else
So.
also.
Right. And so the goal here, right, is to be as explicit as we can, right, about where we expect the exception to happen. This is why the expected exception attribute is so dangerous, because especially, as I said before, right, if you're catching NREs or invalid args or, you know, whatever it might be, right, if you're catching a framework exception that could be anywhere, right, depending on how your code is being invoked. So we want to be really, really careful about that. So the next thing we want to take a look at is, let's take a look at database dependent testing. So I have a series of persistence tests, which, let's just start with the test and take a look. So I have a customer repository that gets and saves customers and does all that fun stuff. Let's look at one of the tests. So for example, right, I have a test that says can retrieve all customers. You notice what I'm doing is I'm newing up an instance of my customer repository, and then I'm just calling get all customers on it, right? So pretty simple, right? Give me a repository, invoke the method, talk to the database, give me the customers. I happen to be using an object relational mapper under the hood, but who cares, doesn't matter, right? What I'm getting back here is an IEnumerable of customers, so if we were to make this explicit, right, we can sort of see that, right? So I get an IEnumerable of customer back. And then all I'm really doing is asserting that the collection of customers has a count equal to 3. Right? Now, in my database, we are in the unit testing talk database, there is, not surprisingly, a customers table, which if we edit the top 200 rows for a second. Okay. So, and obviously they all have my name, but whatever, right? The point is, what you can see here is there's substantially more than 3 customers in the table, right? And that's because I've been working on the application and I've been testing whether or not the add customer page works properly. And I keep typing my own name in and hitting save, and then, you know, because I'm lazy, instead of running a test, I just look in the database, right? Is it really working, right? So I'm working away on the database, and I say to myself, I need to run the database tests. So let's run the database test. right? So can retrieve all customers. Let's run that and see what happens. And it takes a while, right? This is one of those longer running tests, right? But you'll notice the result is 1 passed, 0 failed, right? And yet I asserted that get all customers got 3. So how the heck did that work, right? Here I am, and I'll refresh the table, and sure enough, there's all the data, right? So how did I get 3 customers out of that, right? So this goes back to the idea that testing against a database requires you to manage and maintain and control database state, right? A given set of inputs should produce the right set of outputs, right? So what are we doing? We're using a combination of our fixture setup and our fixture teardown and so on in order to actually fill the database full of the test data we expect, right? So what I'm going to do is I'm going to come over here and put a breakpoint at the beginning of my test, which is can retrieve all customers, right? So right now, right now, and I'll hit refresh, right? The table contains whatever the heck that is, right? 6 records of customers. And now I'm going to run with the debugger, of course, because I need to stop. Okay, now I've hit the breakpoint. So I'm coming back in here and I'm going to refresh the table. There are 3 customers there, right? Because otherwise, how the hell is my test going to pass? Right? There has to be 3 customers in the table. Otherwise, I have inconsistent input to my test, right? So I've got my name, Brian Donahue, a friend of mine from Philadelphia, and Bill Gates from Redmond. And there's our 3 customers. And this is why the test passes, right? Now, if we let the debugger run out to done, eventually the test will pass. There we go, right? 1 passed, 0 failed. And if we come back in here and refresh the table, there are my 6 customers back again, right? So what's really going on here, right? What's going on here is that in the test setup process, I am persisting the current state of this table outside of the database. I am loading it full of the 3 customers I expect to be able to assert against, running my test, and in the teardown, I am returning the original data I pulled out of the table back into the table. So that, at the end of my test run, I haven't lost any data that I've been mucking around with that I was working on before I bothered to run my tests, right? Because otherwise, maybe I need these 6 customers for some other part of the system I'm working on, right? I don't want to lose all that I just spent the morning typing in there in order to get the system into just the right state for the feature I'm trying to add, right? So what's really going on here is that we're using, oh, sorry, do you have a question?
Well, I was wondering how you pull that off without getting some pretty massive blow-ups every time you try to add a column, for example.
Right. So let's talk about that, right? So, and you're right, you do, right? Because this is another thing that must be kept in sync with the database schema, right? That's absolutely correct, right? But if you think about it for a minute, the test will fail, which is actually probably right, because your schema no longer matches the test, right? The test data is not right anymore, right? So yes, you're quite right. You do need to keep this in sync with your schema, right? So as your schema evolves, you do have that problem. So let's look at what's going on here, right? So we are taking advantage of a framework in an open source project called NDB Unit, whose job it is to manage database state before, during, and after tests, right? And I've got a base class here that does the real work. You can see that my customer repository test inherits from database unit test base, which actually does the real work. So in the test fixture setup method in my customer repository tests, I am calling the base class as database fixture setup. This takes, right, remember fixture, right? The fixture setup and teardown runs once before all the tests, and then the teardown runs once after all the tests, right? The setup runs once before every test, and the teardown runs once after every test, right? So in the test fixture setup, I'm taking the current state of the database and persisting it out to disk. Then in each setup, I am refreshing the customer table, right? It's what allows me to run a test like can store customer, right? So if I run can store customer, now there are really 4 customers in the database, right? So if I were to run can store customer and then can retrieve all customers, how would I get back to 3? right? Before each test, I must reload the expected test data, right? And in the teardown, when I'm done, we clear out all the test data and we reload the data at the state of the database as it was before we ran the test suite, right? And that allows me to get back to where I was before. Now, yes?
What about if you've got dependent fields, like if the orders had relations on some of those customers that are just deleted or just pulled out of there?
So the way this works is it's not a table by table basis, right? It's as many or as few tables as you need, right? So as an example, the way this works is this XML file describes the actual data in question, right? So here's customer, right? And there's, me and Brian and Bill Gates. Here is the order, right? So at the same time that we're inserting the customer table, we're also inserting test data into the order table. The order table is dependent on customers, right? You can see that here is a foreign key customer ID in the orders table that points to the customer table, right? So my test data has to be referentially consistent, right, amongst itself. But it doesn't need to be consistent with the entire database. So imagine that we have a database that's got 30, 40, 60 tables, whatever it is, right? In order to test customers and orders, if that's all the referentially consistent data, I can just load customers and orders. I don't need to worry about all the other tables. I can leave them alone, right? So accounting tables, shipping history tables, whatever the heck it is, I can leave those alone. Unless they have foreign keys that point in here, in which case my whole data set needs to be consistent, obviously, in order for the system to insert it, right? You don't get sort of magical, we'll fix foreign key problems for you, right? But if your test data is consistent, and it should be, right? Otherwise, you can't really trust your test manipulating it, right? But if your test data is consistent, then the framework will basically load that stuff in there at the beginning of the test, run the test against it, and then pull it back out again, right, at the end. Now, will this work well if you have 50,000 customer records? No, absolutely not. But I would submit that you don't need 50,000 customer records in order to test whether get all customers really does get all customers. What you need really is just more than one, right? So the intent here is not for you to use this as some kind of secret way to perf test your database, right, or your whole app or anything like that, right? But instead, to think carefully about really how narrow or how broad a data set you really do need in order to test the behavior of your system, right? In the case of adding a where's my repository desk, right? In the case of can store customer, for example, right? All I really need to do, I don't really need any test data, quite frankly, right? This could move somewhere else, right? All I really need to do is make sure that I can insert a customer and then I'm asking for the customer back by that new ID and I'm making sure that they're the same object, right? The customer that I had and I persisted is the same as the customer I get back, so I'm happy, right? This actually requires no loading of data, right? In order to speed this test up, I can move this over to some place where I start with a zero database, right? And just insert a customer, because that's all this test is really doing, right? Insert it, query it back, right? So a little bit of thinking about this, right? But the point of this exercise is that what's really going on is we're talking about managing database state. This is why the shared development database doesn't work, right? None of these, well, maybe the insert, can store customer might pass no matter what someone else is doing. But certainly the can get all customers is unlikely to work well if I'm hitting that database with my test at the same time, some other developer is busy sticking too many Steve Bolins in the database, right? My test is going to fail because I don't have an environment I can control, right? Yes?
I'm assuming it's anti-pattern, but what's wrong with using a transaction rolling back at the end of the test?
Absolutely nothing. The problem with the transaction is it doesn't solve the problem of how do I get the data into the right state to start, right? The transaction solves the rollback. How do you get the data right to start the test, right? So if all these customers are in here and you do the test, you start a transaction and you go can get all customers and assert that there are 3, this test will fail.
Start your transaction, delete everything, insert your test data, and roll back to the end.
Right. So you can do that, right? The problem with that is that if you think about it for a minute, what happens if you hit a breakpoint in the middle of the transaction and then you cancel the test run? How do you get back? Right? The happy path works. It absolutely does, right? But the unhappy path is a world of hurt. So I've seen people manage database state by scripting at the beginning of their test fixture setup, the OSQL command line and restore a database from backup, right? That works too. It's slow as heck, but it works. So there are all kinds of different ways to do this, right? This one, using this framework, what it does is it solves the problem not only of rolling back, which is the transaction will help you with, but it also has the infrastructure to help you with the data loading part too. And as importantly, it persists the data that you start with before you run the test suite out to disk, so that you have that snapshot to restore should anything go wrong with your test in the middle. Right? You had a question?
Does that work also with like even Oracle databases or?
Yes. So NDB Unit actually supports SQL Server, Oracle, Postgres, Firebird, SQLite, and I believe there's one more we have in there. MySQL, thank you. I was going to say I'm missing a big one there somewhere. Yeah, MySQL as well, yes. Just something to think about, right? The important thing is less the mechanics, right? I mean, I'm not trying to, it's an open source framework, you're welcome to use it, I'm not trying to hump it or anything, but the point is less how you do it, right? But that you need to do it, right? Recognize that database dependent testing, just like any other testing, is about controlling the environment wholly in which the test runs, right? And sharing resources isn't going to work if you're trying to control the environment well, right? Okay, so lastly, what we're going to do is we're going to look at mocking hell. And I think I've got a good one. Let's see if I can find it. Yeah, here's a great one. Okay, so this is not uncommon as a unit test using lots of mocks, right? So what this says is when shipping a valid order, we can ship items, right? So you can see again, right at the beginning of this test, I am constructing a number of valid items, right, which we know from our past experience requires a non-zero cost and a non-zero quantity and all the rest of that. So we'd like to abstract this behind some kind of builder pattern too, right, so we don't keep seeing all this new stuff going on here. But now we get into some fun things, right? So I'm creating a list of T where T is a shipping item, and apparently, if I recall my domain properly, the way we construct a shipping item is we pass in like an item from our catalog, and that magically converts it into a shipping item that we can ship, right? Then what we do is we create an order, and we add both items to the order. Then what we do is we create a customer, and the customer has a postal code. I'm pretty sure that's because we can't ship to a customer without a postal code as part of our business rules. Then we add the order to the customer. Then what we do is we get this approver thing, right? And I'm creating that as a mock because I don't really want to bother to go through the whole approval process and everything else. So what I'm doing here, for those of you that aren't familiar with mock object frameworks, this one happens to be Rhino mocks, but the syntax for others is somewhat similar, but let's just go through this, right? So what I'm doing is I'm saying, I've got this thing that's an approver, and I'm going to call generate mock of T, where T, in this case, is I order approval service, right? That's going to return me an I order approval service as my approver, right? So I've got one. It's not my implementation, it's just my the mock framework builds an order approver and I order approval service for me. And what I'm going to say is I'm going to say approver, the service, dot expect. And I'm going to say that I'm going to expect that is valid to ship will be called, and it will be passed the customer and the order. And I don't really care what the arguments are, so we're going to say ignore arguments, who really gives a damn. When is valid to ship is called, I want you to return true, and I don't care how many times this gets repeated. Right, so what this line really says is, I want you to create an instance of I order approval service. And whenever someone calls is valid to ship, with any arguments, I don't care, however many times, I don't care, I want you to return true. Right? And if we think about it for a minute, that's actually kind of appropriate for our test, because our test is, right, when shipping a valid order. So if the order is valid, it seems reasonable that the order approval service should just return true. Right? Because our assumption is it's valid to ship. Right? Now, as part of our process, we also need a iWarehouse service, whose job it is to go to the shelf and get the thing in order to get ready to ship it, right? So we're doing the same thing. We're generating a mock of type iWarehouse service, and we're saying expect that someone's going to call get items for order, right? Because the warehouse service needs to get the items for the order in order to ship them, right? When that happens, I want you to return shipping items, right? What is shipping items, right? Well, shipping items is this object we created way up here, right? Where we basically created this collection of shipping items that was one shipping item each for each of the items that are in the order, right? So we pre-created this result way up here, right? So that when the warehouse goes to get the shipping items for the items in our order, it can just return those shipping items for us, right? Now our next step in the process is we have an order dispatcher. So we need an instance of the iShipping dispatcher service. And we'll expect that we're going to call ship to customer and shipping items. Right? So we're saying we're getting ready to ship, so we need the dispatcher to do the work. We're going to pass it to customer and the collection of shipping items, and dispatcher, please do your work. Right? And then what we do is we create a new order shipper, and we give it the approver and the warehouse and the dispatcher. Right? So these three mock objects are being passed into our order shipper object. And then all we're going to do is we're going to call shipper.ship and pass it to the customer in the order. And then what we're doing here is we've got three lines that all look the same. We're saying dispatcher verify all expectations, warehouse verify all expectations, and approver verify all expectations. In the mocking world, this is the equivalent of our asserts. Right? Remember this line up here, for example, where we said dispatcher.expect, right? When we call dispatcher.verify all expectations, what the mocking framework is going to do is it's been watching the objects it created for us as we're executing our test. And if the expectations we put there haven't been met, it's going to fail the test for us. Okay? So in essence, right, this is sort of the opposite of what we like to call state-based testing. Right? State-based testing is like what I did with can I add the order to the customer, right? I set everything up, I perform some kind of action, and then my assertions are about the state of the system at the end, right? Like the customer has the order I added, right? The first test we looked at was like that. This is a type of testing called, typically referred to as interaction-based testing, where we're not testing the state of the system, we're testing the interaction between different objects in the system. And the way our test fails or passes is based on whether or not those interactions are what we expected. Okay? So at no point am I saying assert, order.status equals shipped. Right? Maybe I should do that. That's a whole other question, right? But what I'm really asserting here is that all of the objects sort of called each other in exactly the way I expected. Okay? Now, this does not, thankfully, evidence the anti-pattern where we're not really testing anything. Okay? But there's almost no way to know that, right? Because there's a lot of noise going on here, right? And if you think about it for a second, very much like up here, where we're saying, I need to create an order item and it has to have a cost of 1 and a quantity of 1, right? This test that's really all about shipping an order, in these two lines, is evidencing intimate knowledge of how to create a valid item. Right? Which is going to make this test break for all kinds of reasons that have nothing to do with whether or not I can ship an order. Right? So we agree that this is probably a problem as a way to approach our test. Right? We should refactor that out into give me a good item, give me a good item, give me a good item, and take care of that. Right? However, if we think about the way the rest of this test is written, right, what we're really trying to do is make sure that we can ship items. So why do we really care, right, if the warehouse really goes to the shelf and gets the item? Is that really about shipping? Right? Do we care about whether the approval really happens? Right? If we are asked to do an approval, it would be nice to return true. But what happens if we stop approving orders? Like all orders are valid to ship. No need to ever bother to check whether or not we can ship them. Right? This test will fail. Even though it's got nothing to do with the fact that we can't ship an order anymore. Right? So what we have here is yet another mock anti-pattern, which is overspecification. Right? And it's not just a mock anti-pattern, it's frankly a unit test anti-pattern, right? We are over-specifying all kinds of details about our tests, right? There are lots of different ways this test can fail. And only one of them really has anything to do with shipping an order. And that's that the dispatcher really gets called with ship to, customer and shipping items. That's really the only thing this test cares about. Right? The rest of this goo is a consequence of the fact that if we crack open shipper, what we'll discover, or order shipper as a class, right? What we'll discover is that in order to do its work, we have to inject an approver and a warehouse and a dispatcher, and then down inside here, when it comes time to ship, we say, if approver is valid to ship, and then when we go to do shipping stuff, way back in here, we're going warehouse, get items for order, right? So what we realize is that this test, sorry, not that one, this test here, right? This test here actually has a horrendous amount of internal knowledge about the way our order shipper class works, right? Way, way, way too much. And if we start changing the way our order shipper works internally, this test will probably fail, even though it turns out we can still ship stuff, right? So what we want to do is we want to sort of loosen this up a little bit, right? So the test is really only testing what we want it to test. The first way we're going to do that is we're going to recognize that in the universe of mock object frameworks, there tends to be an important distinction between mocks and stubs. And the difference is this. On a mock, if you set an expectation and that expectation is not met, the test should fail. On a stub, just like the name sort of suggests, the stub is really just a placeholder. It's there because the compiler sort of demands us to have an object of that type. But in the case of a stub, if the method is never called, then the test will still pass, right? So the stub is sort of a, you know what, I have to have an I-order approval service, but I really don't care what it does, and I don't care when it does it, and I don't care any of this stuff, right? So the first thing we're going to do is we're going to change our I-order approval service to be a stub. Because if we stop approving orders, we don't really care, right? The other thing I'm going to do is I'm going to get rid of this. I'm going to set that to null, and I'm going to set that to null. Because we're already saying ignore arguments. Why bother saying we're going to pass these things in, right? Let's be even more generic about this, right? And originally, right, I didn't actually have repeat any on it, right? But repeat any is a great one because it basically says, I don't care how many times you call this, right? When I don't say repeat any, what it basically means is I'm going to expect this to be called exactly once, right? But I don't really want that, so we are going to leave repeat any in there because I don't care. Call it 0, call it 100 times, doesn't matter how many times you call it, right? Because only by cracking open the order shipper class and staring at the internal private methods do I have any idea how many times it's called, right? And I shouldn't be able to do that, right? I happen to own that class, so I can open it up and I can stare at it, but my test has inappropriate knowledge of how many times that method's going to be called, right? So same thing here, right? I don't really care if the warehouse goes to the shelf and gets the item, so we're going to change this to a stub, and I'm also going to say repeat any, because I don't care how many times it happens, right? I'm even going to say, let's pass in null, because I don't care what the arguments are anyway. We do need, actually I don't even think we need to return shipping items now that I think about it. No, I'm sorry, I do, because we actually do need them for the dispatcher, right? So that's still got to happen. And then the dispatcher we're going to leave as a mock, because that actually is the thing whose behavior we want to assert on, right? And we are going to get rid of both of these lines of code, right? Because the only expectation we really want to verify is that the dispatcher shipped the thing.
So you want to leave
dispatch
dispatcher there?
dispatch.
Oh, I'm sorry. Thank you.
And do you want to ignore all arguments on your second stub as well?
I probably do if I didn't. No, I did, right?
On the first one.
Well, they are null, right?
You did on the approver, but not on the
Ignore
warehouse.
all, ignore arguments method.
Oh, here you mean? Yes, absolutely. In fact, I'll need to, otherwise this test won't pass. Right? Because I've got null here. Yes, so you're quite right. Ignore arguments, right? Thank you. 60-man pair programming. So, the point is, right, that what we've now got is we've got exactly one expectation, right? Exactly one assert, right? That the dispatcher is going to ship the thing, what we call shipper.ship, right? So, what I will tell you as a general pattern, right, to avoid overspecification problems, right, is that when you're using mock object frameworks, and the names for these change a little bit as you move from framework to framework, right, but every mock object framework has a notion of some type of fake that you can create where an expectation not satisfied will fail the test, and some kind of fake object you can create where an expectation not satisfied is just ignored, right? And so what we want to do as a pattern when we're dealing with mock object frameworks in our tests is we want to try and get ourselves to a point where we've got exactly one mock object and everything else is stubbed, right? Exactly one thing whose behavior we're testing and everything else is sort of there to satisfy the compiler and make it happy, okay? And then we want to assert on that one mock object, right? And we want to make the other stubbed objects as stupid as we can get away with, right? So things like repeat any, I don't care how many times you're called, right? Things like ignore arguments, I don't care what you're called with, right? In certain places we can't get away from it, like we do have to say, you know what, when this gets called, do return the shipping items, and by the way, anytime anybody bothers to ask for approval, we do need to say true, right? So oftentimes we can't get away from hard-coding return values like this, but we can get away with loosening expectations on the rest of the objects that are collaborating together, right? And so the best way to avoid asserting on the wrong things, and more importantly, ending up with really sort of tightly coupled tests to code, where the test knows way too much about the internals of the other objects, is to try and be as loose as you can get away with the expectations on these objects as you choreograph them together. Okay? So, that is the end. So, again, if there are any comments, by all means, please let me know. Otherwise, are there any questions that didn't get to be asked during the talk? One.
You mentioned extension methods to add more methods to assert.
Yep.
I didn't know you could do extension methods on a static class.
You can't.
Yes, you're right. I'm sorry, I misspoke. You're right. Usually what I'll do in those cases, I'll put the extension method on the object I'm asserting about. Right? So, you know, maybe I'm asserting about customer or I'm asserting about order. So a good one is when you're doing things like, you know, asserting that the customer is gold status and those kinds of things, right? You can say assert customer.status equals gold, or you can say assert customer is gold status, right? And bury that equals comparison inside the extension method, which is usually what I end up doing, right? Because you want to try and part of the challenge, right, is you want to make sure wherever possible that we try and make sure. Let's see if we can find my customer test here. No. What we're trying to do, right, in general, is, there we go, when customer has an order. What we're trying to do is we would like to make sure that all of our test is written at sort of the same abstraction level, right? So when we're talking about, you know, can add order and adding order and these kinds of things, we then want our assertions wherever possible to also be stated in business terms, right? So when we start getting into like, you know, this equals this and this not equal that and this greater than 0 and so on, usually that test, like this is greater than 0, is actually really secretly a business case, right? So when it's greater than 0, something is the case, right? So when it's greater than 0, the customer is a gold status customer, for example, right? So we'd like to be able to state our assertions in terms of that too. So if we say assert customer is gold customer, then that's an easy assert for us to understand, and it buries the fact that what's really going on is something is greater than 0, for example, right? But our test can remain sort of in business logic. So we'll append sort of verification methods on top of the, you know, on the actual objects under test in order to make it easy for us to express our assertions in business terms. Does that make sense? Yes, but you're quite right. You cannot extend the static class. Shame for you. Anybody else?
All right, not to extend it, but you went through a whole presentation talking about unit testing and didn't mention test-driven development. So what's kind of your opinions?
Yeah, so the reason I didn't is because, of course, these patterns and anti-patterns are equally applicable, whether you're doing test first, test after, test during, test at midnight, test whenever you're doing them. I personally am a big fan of test-driven development. I think that it is something that I have found personally radically increases the quality of my code in ways that I probably would not be able to do otherwise. I think that it's challenging to get people to start doing unit tests in a TDD way because unfortunately the problem I find with unit tests in general is that it's something that everybody should be doing. It's something most people try once. And it's something that until you get good at it is very, very painful to do, right? Unfortunately, we want to say, like, I'm a crackerjack coder, so I'm sure I'll be really good at writing unit tests, right? And that's not true. And the problem is that when you're not good at writing unit tests easily end up creating more pain for you than not. And so it's the kind of thing where one of the reasons that I like doing this talk is because I'm trying to share sort of some of the pitfalls that I've experienced in my own sort of career dealing with testing. Because until you get good at it, it's not the kind of thing that's going to really be that beneficial for you because the pain it's going to cause is going to be too great. And so when you take, I think you should do this new thing that causes you pain, and I also think you should be doing TDD, which is an entirely new process for yourself. It's very challenging to get people to adopt both of those at once. Now that being said, it's very difficult to retrofit tests onto a software system where you didn't think about testing as you were designing it, right? So a lot of times we talk about design for testing, design for testing, design for testing, and what people say is that doesn't make any sense, right? I mean, I should be designing to solve the software problem. If I'm designing my system specifically for testing, that seems like sort of tail wags dog in a weird sort of way that doesn't sort of sit right with me, right? But the truth is that what you find is that the very same, we'll call them concessions, right, or responses that you need to make in your software and engineering choices in order to make your code testable turn out to be the exact same things that make it flexible and adaptable to changing requirements over time. And so the benefit I see to TDD is not so much that you end up with testable code as it is that you end up with code that is designed well and able to be flexible and extendable and all the rest of those kinds of things. It's a side effect of designing, of the test driving it, that you'll end up with that design, right? But the benefit really isn't so much that it's testable, it's that you just end up with good code, right? And once I sort of got my head over the hurdle of, yes, it is testable, but what's really going on is that a side effect of it being testable is that it's actually a better software solution. Never mind the fact that it can be tested, right? Like one school of thought, and I'm not sure I'm against this actually, is test drive your solution, then throw the tests out, right? Because on some level, they've already done their job, right? You've ended up with a loosely coupled, well-isolated, coherently designed, carefully thought out software system that has all of these seams in order to put tests in, right, which is what really forced it, but also in order to put new features and new capabilities in, right? You use those same seams that exist between your objects in order to inject mocks and these kinds of things are the same things that allow you to inject a different instance of the order shipping service. When today we only ship things via air freight and tomorrow we want to ship via ground freight, right? The fact that I had to design this thing so that I could inject the shipper into my code as part of being able to test the thing properly and mock out the shipper and all that, a side effect of that is that now I can inject any shipper I want. Right? Today we ship 3rd day ground, tomorrow we ship 9th day air, whatever it might be. My code's already able to react to that by just me in production injecting a different shipping service thing into that class, right? So a very real side effect of this approach of test-driven design is that you get this much more flexible code base, right? That said, I find that proselytizing test-driven development tends to turn more people off than it brings on board, right? And so I definitely do not touch on it. I have another talk entirely on TDD, but this one I don't really go there because I really think most of what I'm showing today is applicable whether you're test first, test after, whatever, right? And so, I can get up on my soapbox and tell you should do TDD. My own personal preference is to do it. I've had some bad experiences with it and I've had some very good experiences with it. On balance, I'm a bigger fan of it than not. But it's certainly not appropriate everywhere. But I would definitely suggest that if you're interested in unit testing and have experienced lots of friction, right, and do have an opportunity to start a new project, then thinking about it in a test-driven approach will make your ability to write tests much easier for it, right? And I believe that a side effect of that is you'll end up with a much better software system. Anybody else? No? Okay. Well, thank you very much for coming out. Appreciate your time.